Have you ever tried to understand something that just refuses to make sense, no matter how hard you think about it? Imagine trying to predict something simple, like where a thrown ball will land, but the ball acts like a splash in a pond and, sometimes like thousands of tiny particles all at once. The double-slit experiment with light is so confusing precisely because it challenges our most basic, everyday understanding of reality. It shows that light, and in fact all matter, exhibits a bizarre dual nature, behaving as both a wave and a particle, and this behavior dramatically changes when we try to observe it. At its core, the confusion stems from wave-particle duality. When light travels, it behaves like a wave, much like ripples expanding on a pond. If you send these waves through to narrow openings, they interfere with each other, creating a distinctive pattern of bright and dark bands on a screen behind them. This is known as an interference pattern. However, light also arrives at the screen as discrete packets of energy called photons, acting like tiny individual particles. The truly perplexing part begins when you try to detect which slit each individual photon passes through. The moment you introduce a detector to observe the photon's path, the interference pattern mysteriously vanishes. Instead of a wavy pattern, you suddenly see two distinct lines on the screen, just as if you were firing tiny marbles through two holes. It is as though the light, or rather the quantum entity, somehow, knows it is being watched and decides to behave solely as a particle, collapsing its wave-like state. This observer effect forces us to completely rethink the role of observation in defining reality at the quantum level. Grappling with this concept means letting go of our classical expectations and embracing the inherent weirdness of the quantum world. Instead of trying to visualize exactly how something can be both a wave and a particle simultaneously, focus on what the experiment demonstrates. It reveals that quantum mechanics operates on rules fundamentally different from the macroscopic world we experience, where things have definite locations and properties at all times. This phenomenon is not limited to light. The double-slit experiment has been successfully performed with electrons, atoms, and even molecules, proving that this wave-particle duality is a fundamental property of all matter, not just photons. This experiment is a foundational cornerstone of quantum mechanics, one of the most accurately tested and successful scientific theories in history. In fact, the renowned physicist Richard Feynman famously remarked that the double-slit experiment contains the only mystery of quantum mechanics, because it encapsulates the central paradox of quantum reality. So, the experiment is not confusing because it is poorly understood or ill-defined, but because it shines a spotlight on a deeper, counterintuitive reality. It reveals that the act of observation plays a profound role in shaping the behavior of the universe at its most fundamental level, pushing the boundaries of our understanding of existence itself, and inviting us to explore a truly mind-bending scientific frontier.